Hey everyone, and welcome back to Summarize Science. Today, we're looking at a fascinating challenge in robotics: how to make a robot move like a human. It's not just about getting from point A to point B, but doing it gracefully and intelligently. Think about all the different ways you can grasp an object: a pinch, a power grip, a hook. These aren't random poses. They're related in a sort of family tree of motions, which scientists call a taxonomy. The problem is, previous AI models were good at one of two things, but not both. They could either understand this family tree of motions, or they could generate smooth, realistic movements. Trying to combine them often resulted in jerky, physically impossible motions, like a robot trying to teleport its fingers. This is where a new paper introduces a brilliant idea: mapping motion onto a special kind of curved space called a hyperbolic manifold. Forget flat maps. Think of a surface that's constantly curving outwards, like the edge of a saddle. It turns out this unique geometry is perfect for organizing hierarchical, tree-like information, like our hand grasp family tree. The researchers developed a model they call the Gaussian process hyperbolic dynamical model, or GPHDM for short. This model creates a map in this curved space where similar hand grasps are clustered together, preserving their family tree structure. But here's the crucial part: they also added a physics engine to this map. This ensures that any path you trace on the map corresponds to a smooth and physically consistent motion back in the real world. They explored a few ways to generate new movements, but quickly found that just drawing a straight line from one grasp to another doesn't work. As you can see here, that straight-line path often cuts across no man's land on the map, which corresponds to weird, high-uncertainty motions. Their most successful technique creates custom rules of the road on their map. Instead of a direct line, this method finds a path that sticks closely to the highways formed by the real human motion data it was trained on. When generating a new motion, like transitioning from a ring grasp to a spherical grasp, this method produces a fluid, believable movement with very low uncertainty. So, to recap, these researchers combined three key ideas: a hierarchy of motion, the unique geometry of hyperbolic space, and a dynamics model to ensure physical realism. This allows an AI to learn a map of motions that is both structurally organized and dynamically consistent. What does this mean for the future? It's a big step toward robots that can generate novel, human-like movements on the fly. Instead of just playing back pre-programmed actions, they could intelligently create the right motion for a new task. This would make them far more adaptable, graceful, and useful in our world. Thanks for watching Summarize Science.